So in this video, we're just going to start bringing together all of the things we've learned about indices and operations with them. And we're going to just attempt a couple of practice questions to get you used to applying these for simplifying questions which otherwise look a little bit messy. But what if we just keep in mind all of our things we know about indices, you'll find that it's not too bad to work through. We just need to attack our things one by one. So here we have a fraction, but on our numerator, we've got a few similar terms, and we have a multiplication happening here. So if we remember from our indices before, that if we have the sum a to the power of m multiplied by that same base, we can add the powers here. So working through this question, we have x to the power of 2 here and x to the power of 4. So multiplying these two terms together, my powers here will add. So that's like saying I have x to the power of 2 plus 4, and that's being multiplied by y, and there's no number up here, but we have one y. So we can think of this as y to the power of 1, just itself. And we have y to the power of 3 here. So taking these, we'll get y to the power of 1 plus y to the power of 3. And this is all getting divided by xy squared. Oops. Okay, now simplifying this, I'm going to have x to the power of 6 on the top here, multiplied by y to the power of 4. And this is a fraction, so this implies that we're dividing by this denominator here. So I'm going to write this as we have x to the power of 6 times y to the power of 4. And that is getting divided by xy squared. Now, when we're dividing here, you may remember from our indices laws we established in the last few videos, dividing these same bases gives us the equivalent of just subtracting the powers here. So I have x to the power of 6, x to the power of 1, y to the power of 4, and y to the power of 2. So my last step is I'm going to work through these two unique terms individually and do the operation. So this is like saying x to the power of 6 minus 1 multiplied by y to the power of 4 minus 2. And the last thing to do here is to just do these operations. So I'm going to get left with x to the power of 5, y to the power of 2, or y squared. And this right here is my simplest form. I can't do anything more with this because x and y are different bases. As we said before, x and y can represent any number, but these two are different numbers, so we can't compute them in the same way. We just have to leave this as a product of x to the power of 5 and y squared. Now that's example 1. We've got one more here. Now, this one may look a little bit scarier, and you may notice that in the previous example I used x's and y's. Here I'm using an actual number as well. And as we established before, our indices rules work the same with algebraic terms as well as numbers. Because algebraic terms are really just meant to represent numbers. So it would make sense that we'd work through this in the same way. Now, let's work through this individually. And especially when I'm working with fractions, I like to personally work through the numerator and the denominator separately, and then compute this division, work through work through the actual last fraction part. Now, it's important to note here that 4x squared y is just one term, and all of that is getting squared. So that means each of these individual elements are getting squared. So if I work through my numerator, I'm going to get 4 squared. And here I have x squared squared. And you may remember that if we have, let's do this, if we have some indice to some power and we applied another power to that power, it was like a power of a power thing, then that was the same as multiplying these powers here. So my x squared squared will be like saying x to the power of 2 times 2. And I'm just going to get y squared here. Now, working through my bottom, I only have one term, one pronumeral, so one just letter, in each of these terms. 4 multiplied by y and x cubed multiplied by y. Now, all of these terms will multiply, but the only index laws we apply is to do with these y's, because they're the only ones between the two terms with the same base. So multiplying these two, I'll get 4x squared, and then y to the power of, both of these are to the power of 1. So I'm going to get y to the power of 1 plus 1. Working through here, and I'm purposely taking this very slowly, working through each step, because a lot of the time when we work through indices, it can get a little bit messy. So that's why I'm purposely leaving things like this here, just so I know what I'm doing. With practice, you'll be able to fly through these a lot quicker, but for the purposes of this video, we're going to take this very slow. So I'm going to have 4 squared here. Now, I could have written this as 16, but I've chosen not to just yet. You'll see why. I have x to the power of 4 and y squared. And that thing, actually, let me move this down a little bit. That is like now dividing by 4 x squared y squared. Now, we have 16 here, 4 squared. When divided by 4, that just gives us 4. But I'm going to write this using indices to show you that the indices communicate the exact same thing to us. Because we have a division, this is like saying 4 squared minus 1. And here I have x to the power of 4 minus 2. And here I have y squared divided by y squared. So any number, we know that any number divided by itself, no matter what number it is, will always give us 1. So here, we can just say, we don't know what y is, but we know that when we square it and divide it by itself squared, it's just always going to give us 1. That is just a property of numbers in general. When we divide them by themselves, we're going to get 1. Now, this is like multiplying by 1, but when we multiply anything by 1, it just gives us that number. So we can just disregard that there because that will simplify. And I'm going to get left with 4 because 2 minus 1 gives us 1. So it's just 4 to the power of 1 or 4. And then we get x to the power of 4 minus 2. We get x squared. Now, these are some examples of how you can work all of these rules we established in the previous videos and actually solve some trickier questions. Actually work through simplifying these types of algebraic terms. I'll see you guys next time.